In this video, we're going to be graphing the inverse of a function. So remember that an inverse is where you interchange the x and the y coordinates. Therefore, when we look at the graph, it is going to be a reflection over the y equals x line, which the y equals x line is graphed here in like a gold color. What I'm going to do is I'm going to go ahead and identify the coordinates of the points that are already graphed here. And then to find the inverse of just those points, we're going to interchange the x and the y coordinate. That will essentially reflect it over the y equals x line. And then I can graph those 2 points, and that will be the graph of the inverse, especially since this is just a line. I can connect 2 points to make a line. Okay, so first coordinate point here is at, it looks like 5, 7. So this coordinate down here is at -1, -5. Okay, so the inverse of those 2 points, if we interchange the x and the y coordinate, the inverse of this point is going to be located at 7, 5. So 7, 5 is right there. Notice that that point just reflected over that y equals x line. The inverse of this point here, if I interchange the x and the y coordinate, is going to be at -5, -1. So graphing that point, -5, -1 is right there. Notice again, it's reflected over the y equals x line. So connecting these 2 pink points or coordinates, that would give me the inverse of that function. I'm probably not going to be able to draw this in a straight line, but I'm going to try here. So connecting these 2 pink points would be a line that's supposed to be straight, and that line would be the inverse of this line that's graphed in black. Okay, same process for number 2. I'm going to identify the coordinates of the x and the y values that are originally graphed here. This one is located at 2, 4. And this one here is at 1, 0. Okay, interchanging the x and the y coordinates of those 2 points. 4, 2. And 0, 1 would be the locations of those points on the inverse of that function. So 4, 2 is here. That's a reflection over that y equals x line of the first coordinate. And the reflection of this coordinate would be at 0, 1. And this coordinate that is on the reflection line would stay. So I could have marked that point on the original one as well. I just didn't. The first one, I should say, the first example. So connecting those 3 points in a straight line, there is my inverse function. Again, a reflection over the y equals x line. Okay, the next example, I'm going to use the same process, but notice these are not lines. So this would be like a square root function, but the process is the same. Identify the coordinates of the original points. So this one is 5, 2, and the first one was at 1, 0. Interchanging the x and the y coordinates there. This first point 0, 0, 1, and the second point 2, 5. If I reflect those over the y equals x line, 0, 1 would be there, and 2, 5. Okay, now notice that this section of the graph is getting further away from the line. I want to make sure I'm reflecting over that line. That's the best I can do there. But it is going to be a parabola shape. So the inverse of the square root function would be a quadratic function. So like an x squared function. So again, that would be the inverse of this function. Okay. Example 4, identifying those coordinates, 0, -4, and 4, -2. The inverse of that function would have the coordinates -4, 0, and -2, 4. All right, graphing those points, -4, 0 is there, and -2, 4. And again, this is a square root function, so the inverse is going to be a quadratic or a parabola. So it's going to have that same smooth curve, parabolic shape as number 3. Okay, our next 2 examples are cubic functions. So when we graph the inverse, it's going to be a cubed root function. Process is still the same. Identify those coordinates. So our first coordinate is at -2, -10. Our next coordinate is at 0, -3. And our third coordinate is at 2, 5. Also, note that any point that's on the reflection line will stay on the reflection line. So this point right here is on the y equals x line. So if I switch the x and y coordinate, that point would stay. I'm not going to identify that coordinate, but I am going to make sure that when I graph the inverse, it intersects right on that point. Okay, the inverse coordinates, switching the x and the y. This one would be located at 5, 2. This point would be -3, 0. And the last coordinate would be -10, -2. All right, graphing those points, 5, 2. And this coordinate here is going to stay here. This coordinate, -3, 0. And the last coordinate, -10, -2. All right, so if I connect these points, sorry about that. My computer's starting to lag here, and therefore not doing what I'm asking it to do. So let me get rid of it. That looks like a straight line. I guess I was just a little bit too slow in trying to draw that graph.